Good day and a very warm welcome to ChartWorld's webinar about the latest IHO publication named S-67 Mariner's Guide to Accuracy of Depth Information in Electronic Navigational Chart. My name is Brugger and I'm the navigation consultant in ChartWorld for the area EMEA. Together with my colleague Wilson Tan, who is based in Singapore, it's our pleasure to support our customers in their implementation process of our products. Coming to myself again, I started working in the maritime industry back in 1990 by going to sea, and then back in 2007 I left sea as master mariner and joined a ship owner and technical manager here in Hamburg. The fleet consisted of tankers and bulk carriers. I was working those days in the vetting department and in the operations department, making sure that our ships, or that the ships those days, are fully compliant with the oil major requirements and following the best management practice. As such, again, also here in ChartWorld, together with my colleague, we are very happy to support our customers in advising on best management practices. And as such, today it's my pleasure to introduce to all of you the S-67, which is part from now on for best management practices within the maritime industry. The S-67 should be seen as a supplement to the previous IHO publication, which is named S-66, Facts about Electronic Charts and Carriage Requirements. However, S-67 now should be seen as a guide to any navigator so as to provide a more in-depth knowledge as to how a navigator should interpret the depth information presented to him by an actors. That's the original wording within this S-67. So what does it mean that the S-67 is providing in-depth knowledge about depth information? Well, it explains in details how to use and how to consider and how to work with CATSOC values, means with categories of zone of confidences, how to consider them in voyage planning while you conduct the voyage. Those things are being explained in depth in the S-67. The use of CATSOC values should not be seen as a problem. They should be seen as an additional safety layer. They will help prevent incidents from happening. And I'm going to explain and show this in a little case study to you. Case study is done basis the investigation report 241, year 2018, issued by Germany's Federal Bureau of Maritime Casualty Investigation. It is about the crowning of the motor tanker Pacific of Indonesia back on July 9th, year 2018. These two pictures have been taken out of the report by showing the vessel sitting on the rocks. We see on the left-hand side the rocks above the waterline and waves breaking on the rocks on the right-hand side. It took 5 days to put the vessel off the rocks again, and under own power she could then proceed to Singapore for repairs in the yard, accompanied by an escort tug. We see here the islands of Komodo and Banta, and in between the vessel grounded. We zoom in again and we see the vessel's track, we see the vessel's voyage legs, and we see that the vessel has set an XTD of 185 meters either side, port and starboard, which is a cable, which is as per company policy adequate, since the vessel is per definition, per company's definition, in confined waters, so XTD to be set one cable to either side. And we see isolated dangers here on the port side of the vessel, and we see further that the CATSOC value, the zone of confidence here, has value Charlie. Charlie means that for bathymetric data, the horizontal accuracy is plus minus 500 meters. If we take now the ERBL and we put it to the isolated danger, we zoom a little bit in, we see that the distance between the coastline and the isolated danger is less than 450 meters. This means the accuracy of this isolated dangers is 500 meters, since the bathymetric data, the underwater object, is located in a zone of confidence Charlie. So vessel is in danger to hit the isolated danger, although on a first view it would pass clear of that. This isolated danger is somewhere here, within 500 meters. It must not be on this position, hence it is located in value Charlie waters. If we now make the auto route check, and we're doing this by clicking on check, we check the route, then we see that the isolated danger, S danger, is not being highlighted, right? It is not, because CATSOC values commonly by actor systems are not being considered. If we would now move this previous waypoint and we bring our XTD over the isolated danger, we see now the isolated danger is clearly marked as danger. Going back, we see isolated danger again is not being highlighted as danger. And as just demonstrated, the e-globe from ChartWorld does not only have a final route check by clicking onto auto route check, it has an online route check, an in-flight check, so to say. Once you're changing the voyage leg, system will check immediately and highlight this visually if there is a danger detected. As mentioned previously, we in ChartWorld believe it is essentially important to consider CATSOC. And CATSOC is not something which comes into the picture only because we're working over the ENCs. No, it is as old as charts. With paper charts, we had the source diagrams, and the navigator was required to check for the accuracy and assess the accuracy of the data. Now it's easier with the ENC. We know what the CATSOC value is about and can consider that in a very smart and convenient way. And we come now to a unique feature of our Actis e-globe G2, which is the only system in the maritime industry being able to consider the CATSOC while doing the auto route check. We go again to check, putting the window a little aside, tick boxing use CATSOC, click on check route, and we see the XTD corridor now still being set to 185 meters either side, has now added the value of 500 meter horizontally, since this is the accuracy for SOC Charlie. So it's clearly marked as a danger and so highlighted to the navigator to give the isolated danger a wider berth so as to stay safe from same, taking into consideration the CATSOC value. So shifting the waypoint, doing this, zooming out, shifting a waypoint a little, you will see the isolated danger now is now outside the entire distance consisting of XTD plus the SOC Charlie value of 500 meters. I hope you find this case study interesting, and you may agree that using CATSOC within Actis manufactured by ChartWorld named e-globe G2 does not cause any problems to use CATSOC. It's just an easy tool, and it's very effective, and it provides simply an additional layer in order to make sure that the vessel gets not into navigational dangers. Coming back to the IHU publication S-67, I have divided my presentation into three parts. Part A will deal with the principal points of the publication. The part B then will give the requirements and the recommendations following the principal points of the publication. And the part C is then the product solution, which ChartWorld offers in order to comply with the best management practice of S-67. So we are starting with the part A, the principal points of the S-67, and it starts very basic. We know that the Katzer classification is based on 3 factors, on a combination of those. That's the depth accuracy, the precision accuracy, and the seafloor coverage. Depth accuracy is equal to vertical accuracy, precision accuracy is the horizontal accuracy, and the seafloor coverage, we all know that, is to what extent it has the seafloor been searched. It further gives another basic information saying that we have 6 categories for the quality of hydrographic source data. 5 of those are being for assessed data and 1 is for unassessed data. You read this: alpha 1 up to delta is assessed, uniform is unassessed. Then we come to the accuracy rating. We've got 3 levels of accuracy ratings: the high, the medium, and the poor accuracy depth information. And we see high applies for the zone of confidence alpha 1, alpha 2, medium for zone of confidence Bravo, poor accuracy depth information applies to zone of confidence Charlie Delta uniform. The Hydrographic Office assesses the quality of data or the accuracy rating for the data basis 2 main factors. Number 1 is source of data. Number 2 is the date of data of the survey. So source of data means if the data is coming from a port, then the data is generally assigned as a zone of confidence alpha 1, alpha 2, randomly as Bravo. Laser data by planes are assigned in general as zone of confidence Bravo, sometimes even alpha 2. Satellite data is assigned as zone of confidence Charlie, while in general private ship owner data is assigned as zone of confidence Delta. But as already said, also the date of data of the survey is a factor. In general, you can say the older the data, the lower the value. This means from the 1940s to the 1990s, survey ships depended upon shore-based electronic position systems, transmitting the signals over short or medium ranges, giving an accuracy of around 20 to 100 meters. In coastal areas, this means the true position of an object could be up to 200 meters away from the charted position. Data prior to 1980s are assigned in general as zone of confidence Bravo, Charlie or Delta, because in the 1980s the GPS receiver delivered an accuracy only of about 30 meters, 30. Now with the DGPS, the accuracy of the standard GNSS receivers is nowadays in a range of 5 meters, and with the full service of Galileo, then the accuracy will come down to 20 centimeters only. When it comes to route planning, following accuracy of objects is to be considered. Isolated dangers and shallow soundings, while planning a route in zone of confidence alpha 1, alpha 2, might be away from their charted position horizontally up to 20 meters, vertically up to 0.5 to 1 meter, shoulder or deeper. No uncharted dangers to navigation exist, hence a full seabed search had been done. Zone of confidence Bravo, please expect that isolated danger and shallow soundings might be away from their charted position horizontally up to 50 meters, vertically at least 1 meter, shoulder deeper. Uncharted danger to navigation is likely to not exist. For zone of confidence Charlie Delta uniform, you may consider horizontally up to 500 meters for isolated dangers and shallow soundings that they are away from their charted position, and vertically at least 2 meters shoulder and deeper, which might be significantly shallower. The existence of seafloor features dangers for navigation is likely to be not identified, though they may exist. Charlie and Delta now here being treated equally by saying that The isolated danger and shallow soundings might be way up to 500 meters from the charted position, but we know there is a table, and we all know this table, giving in details the horizontal and the vertical accuracy for the different zone of confidences. This table, which is also part of this S-67 publication, as Annex Alpha, says Charlie is plus minus 500 meters, delta but delta is worse. So we brought this up against the IHO, saying it appears to be there is a document inconsistency in the executive summary and text item, the executive summary and text item 413. This is the same I just displayed here in conjunction with the table of the Annex A. The IHO was coming back and saying thank you very much for helping us improving our publication S-67, and now within the next edition we will have an amended wording for this section, and you read here in bold type. It will then be said that for zone of confidence Charlie Delta uniform, the mariner should consider that isolated danger shallow soundings could be up to and possibly exceeding 500 meters away from their charted position, and possibly exceeding will be then the amended wording. But what is now the difference between zone of confidence Charlie, Delta and uniform if the mariner should consider a horizontal accuracy up to or even possibly exceeding 500 meters for isolated danger and shallow soundings from their charted position? Well, the S-67 is saying for zone of confidence Charlie, you exercise caution, hence uncharted danger to navigation may exist. For zone of confidence Delta and uniform, you exercise very high degree of caution, hence those uncharted danger to navigation may exist. So that's the only difference between the zone of confidence Charlie, Delta and uniform. Further, the S-67 says that during the route planning you need to consider a horizontal accuracy when considering to set the cross-check distance for the auto route check. It is also saying that a full portfolio of ENCs at the appropriate scales is to be available for the intended voyage. Last but not least, the S-67 is also referring to overscaling. As we know, the Act allows the mariner to overscale, however, this is not recommended. Why is it not recommended? Because we have two different objects on an ENC. We have point objects and we have area objects. An isolated danger is always a point object. A point object will not change its size. It doesn't matter how much you zoom in or how much you zoom out. It will remain. In this example, this is an isolated danger, the point object, and we have a width of 7 millimeters. On the lower left-hand side, you see the ENC in original scale, and on the lower right-hand side, you see an overscaling, clearly indicated by these vertical lines. The lower right picture might be misinterpreted in a way that the ship is clearly passing from the isolated danger, but it does not, because the isolated danger, as already said, remains in its size, while other area objects, such as the ship, such as the 30-meter depth line, such as the dangerous underwater rock of uncertain depth, this is the blue field with the two pluses, those area objects getting bigger or smaller depending on how much you zoom in, zoom out. As I said, it does not apply to the isolated danger, which is a point object. So that's why the S-67 does not recommend to overscale an ENC in an ACTIS. Part B. Requirements and recommendations following the S-67. Actually, we see two requirements, basis the principal points of the S-67. Number one is route planning require in general consideration of accuracy of catstock. You need to consider the accuracy of the category of zone of confidences, and the horizontal accuracy is always to be considered when you set the cross-check distance for the auto route check. Those two requirements we see following the S-67. Coming to part C, the ChartWorld products in order to comply with the best management practice of S-67. The route planning requires consideration of accuracy of CATSOC, and we've seen that in the case study. That is very easy to be done with ChartWorld's eCloak G2 by use the views CATSOC function. But how to prove this against third parties? Well, the MIRA, which stands for the My Route Appraisal, is ChartWorld's latest voyage planning tool. And the predefined voyage plan, as it is provided by the system, will show and will display for each single voyage leg the CATSOC value. So it's very easy to prove against any third party that CATSOC has been considered during the voyage planning. Number 2 requirement is to consider the horizontal accuracy when setting the cross-check distance for the auto route check. And I demonstrated this already, that our eCloak G2 does this automatically once you click the Use CATSOC button. And we will go not into depth again. As I said, I explained this already. Now we're coming to the end of the presentation and the webinar. And all I have to say is thank you very much for your attendance. I hope you find it interesting. And in case of any need, please do not hesitate to contact me via the displayed email address. Again, thank you very much for your attendance and looking forward to welcome you soon to ChartWorld's next webinar, likely to be available end Q1 2021. Stay safe and all the best.